So let's talk about our last quiz and see how we did on it and what we did correctly, maybe some things we need to improve on. Looking at number 1 to start with, we're multiplying in scientific notation. And our rule when we multiply in scientific notation is we multiply our numeric pieces first out front, and we multiply our base 10 pieces second. So when I multiply 9 times 10 squared and 3 times 10 to the 6, I multiply my numeric pieces, I get 27. I multiply my exponent portion, 10 to the second times 10 to the 6th. When multiplying with the same base, we keep the base and we add the exponent. 27 times 10 to the 8th. But that's not the correct answer because it's not in scientific notation until we fix the exponent. So remember our rule, we move left, we add. If I move to the right, I subtract. So my correct answer here would be 2.7 times 10 to the 9th power for that problem. As I go on to number 2, I see I have a multiplication problem, 1.2 times 10 to the negative 4th times 7 times 10 to the 4th. Keeping in mind we have our calculator here. I think I know 1.2 times 7 is 8.4, but let's verify it. If I do 1.2 times 7, I'm getting, well, helps if I can move my calculator out of the way there. There we go. We get 8.4. So that's what I get when I multiply my front numbers, 1.2 times 7. I see it's 8.4. And I like that because I know I don't have to change it. Remember in scientific notation, this front number is between 1 and 10, already between 1 and 10, so I'm not going to have to make any changes there. I just have to make sure I do my base 10 portion correctly, 10 to the negative 1st times 10 to the 4th, multiplying with the same base, keep the base, add the exponent. I'm getting my answer here of 8.4 times 10 to the 3rd power. Make sure when you input it that you use your 8.4, and we have to use the times button right here, not the X. Had a few people make that mistake, went back and gave them some credit for it even though we told you, but just be careful, make sure you're entering correctly. 8.4 times 10 to the 3rd power. And we'll move on to the next problem. So as I look at number 3, I'm looking at the same basic type of problem, but be careful. Notice this is the division problem. We see that division sign in between the two of them. A lot of times we see that written as fraction, but it can be written that way. So we're going to do the same thing we've been doing. I'm going to take 6, I'm going to divide it by 2.4, and I'm getting 2.5. And then I'm going to subtract my exponents, because how do I divide with the same base? I keep the base, and I subtract the exponent. So this exponent right here is going to be 2 minus negative 1. First exponent minus the second. And you have to be careful. If I do 2 minus negative 1, using your calculator, using your rules that hopefully you learned from last year, keep, change, or add the opposite, I see my answer should be 2.5 times 10 to the 3rd power. And again, we'll input that here and make sure that we enter it correctly, 2.5. Make sure you use the time button, 10 to the 3rd power, and hopefully we did it correctly. Moving on. Look at the number 4, same basic idea. You're multiplying and dividing. You do the math with the front numbers, and you change the exponent. So I'm going to do 4.5 divided by 7.5. If I'm not mistaken, I get 0.6 when I divide those two out. When I divide with the same base, I keep the base and I subtract the exponent. So this number right here is going to come from taking negative 8 minus 3. Watch your mistakes. That's a common mistake, is subtracting those negative. If I take negative 8 and subtract 3 from it, I should see negative 11. So I divided my numeric portion. I divided my base 10 portion by keeping the base, subtracting the exponent. And now I have to make my adjustment, right? Because it's not in scientific notation. This number is too small. It's not between 1 and 10. So I move to the right. If I move to the left, I add. If I move to the right, I subtract. So I subtract 1 from that answer, and I get an answer of 6 times 10 to the negative 12th power. If you put that as 6.0, that should be okay as well. There should be my answer for that problem, making sure we enter it correctly as 6 or 6.0 times 10 to the negative 12th. And we move on to the next problem, looking at number 5. Now we're adding and subtracting, and this is what we have to remember. Part of what we learned was when we add and subtract, I can't add and subtract until this exponent right here is the same. That 4 and that 5 aren't the same, so I have to make some adjustments to that first. Because our first step with adding and subtracting is making sure we have that same exponent piece. So I'm going to take the smaller and I'm going to change it to 10 to the 5th. And when I change that, I just added 1 to this. So what's our rule? Left add. So since I added 1, I'm going to move it to the left and make it 0.5 times 10 to the 5th power plus 4 times 10 to the 5th power. Once that exponent is the same, now I can do my math with the front numbers. 0.5 plus 4 is 4.5, and when we add and subtract in scientific notation, or any time with exponents, we keep that exponent. We don't change the exponent when adding and subtracting, only change the exponent when multiplying and dividing. So let's put our answer in, and I'm seeing 4.5 times 10 to the 5th power. So look at number 6, same basic idea. Different exponents, have to make the change. I have to change this to make it look like that. I'm going to change this smaller, make it look like the bigger. So 10 to the negative first power, I just added 3 to that. And if I add 3, I move to the left 1, 2, 3 spots. So this should be 0.0059 times 10 to the negative first. And I'm adding that to 8.5 times 10 to the negative first. Once our exponent is the same, we can do our addition subtraction with our front numbers. 8.5 plus 0.009 is 8.5059 times 10 to the negative first power. Be careful entering that and make sure we did it correctly, but that should be our correct answer without borrowing any silly mistakes. And one thing I'm doing as I go through this, before I move on, I'm checking my number and make sure it matches that. It'd be really easy to leave that 0 out or do something silly like that, or to mess up the exponent by not putting it as an exponent. So make sure you're checking these as you go and doing these correctly. Let's see what number 7 looks like. For number 7, seeing a very similar type of problem, only this one's subtraction. So I'm going to do the same thing. I'm going to make my smaller exponent look like my bigger exponent. I'm going to add 1 to that. So that's going to be 10 to the 9th power. If I add 1, I move to the left. Left add, right subtract. I have 0.9 times 10 to the 9th power subtracted from 2.7 times 10 to the 9th power. And once our exponent is the same, we can subtract our front numbers. 2.7 minus 0.9 looks to me like 1.8. Adding and subtracting exponents, keep the exponent value once they're the same. 1.8 times 10 to the 9th is what it looks to me like. So let's move on to number 8. We'll check these and see how I did in just a minute or two. Another subtraction problem, same rule. We're not changing what we know. We're building on it. So I'm still building on those exponent rules that we learned not too long ago. I'm going to change my exponent, making the smaller larger. 10 to the negative first. I added 1 here, so I moved 1 spot back. This becomes 4.5 times 10 to the negative first. Haven't changed that. Subtracting 0.2 times 10 to the negative first. Made our exponent the same. Do your math with 4.5 minus 0.2. I'm getting 4.3, keeping the base and the exponent when adding, subtracting. 4.3 times 10 to the negative first power. And again, before we move on, let's make sure we didn't do something silly like forget the 10 or do something, but make sure our work and our answer look the same. Then we get to a couple of word problems if I'm not mistaken. Let's look and see what number 9 looks like. And might need to give myself a little room here. There we go. So it tells us that an online company ran a 2-day sale. It generated 6.2.5 times 10 to the 5th power on the first day and 1.9 times 10 to the 6th power on the second day. Find the combined revenue. Combined revenue tells me I'm adding 2 things together. So I'm going to add my 6.2 times 10 to the 5th, my 1.9 times 10 to the 6th. Let's set it up. And once it's set up, we recognize addition. We have to have the same exponent. Make your smaller number your bigger number. This is going to be 10 to the 6th power. I add 1 to that, so I move to the left 1 spot. I'm getting 0.62 times 10 to the 6th, adding to that 1.9 times 10 to the 6th. That's going to be a times 10 to the 6th power. 0.62 plus 1.9, I believe, is 2.52. Doing some mental math now. Be careful. Make sure we don't make silly mistakes with it. Hopefully I did that correctly. If not, we'll go back and make corrections as needed. I got my work shown. We can see where my mistake may be, but hopefully we did pretty good on this. So 2.52 times 10, and we will leave that to the 6th power. Didn't catch that exponent, did it? To the 6th power. See, little mistake that would have cost us. And I'm making all kinds of problems here. But again, I'm catching them. Why is that not working for me? 2.52 times 10 raised to the 6th power. For some reason, there we go. Control pad wasn't working there, but let's double check all those little mistakes. 2.52 times 10 to the 6th before we move on. Yeah, we did it. We got it correct. And then we have our last problem. Approximately 6.5 times 10 to the 7th people fly commercially on the United States each month. Approximately how many people fly commercially each year? Express your final answer in scientific notation. And because we're super nice, we remind you there's 12 months in a year. So let's set up our problem. When I multiply this out, I'm going to multiply those. 6.5 times 12. I'm getting that to be 78 times 10 to the 7th power. We've done several problems like that on our worksheets. I move the decimal left one spot, so I add 1 to my answer. I'm seeing 78, or 7.8 I should say, times 10 to the 8th power as the number of people who fly annually. So 7.8 times 10 to the 8th power